So welcome to the 7th lecture on Laplace transform. So click on the I button to view all the other lectures in Laplace transform. So here in this lecture we shall deal with Laplace transform of derivatives. So let me consider the Laplace transform of the given function f of t, which is equal to f of s. Then the Laplace transform of f dash of t is equal to f of s minus f of 0. Similarly, what is Laplace transform of f double dash of t? It's going to be s square f of s minus s f of 0 minus f dash 0. So similarly, what is Laplace transform of f n of t? That is the nth derivative of f of t. It is s power n f of s minus s n minus 1 f of 0 minus s n minus 2 f dash of 0 and so on minus f n minus 1 0. So let's take a few examples and see how we can apply this formula. F of t equals e power minus 5t sine t, and we need to find the Laplace transform of f dash of t. So to find f dash of t, we first have to find f of s. So what is f of s? F of s is Laplace transform of sine t. Sine t is 1 divided by s square plus 1 square. And since the given function is multiplied by the exponential, we have to use the first shifting theorem where s is translated by s minus a or s plus a. So here a is minus 5. So a is minus 5. So wherever s is there, replace it by s plus 5. So it's going to be 1 divided by s plus 5 the whole square plus 1. So it's going to be 1 divided by s square plus 10s plus 25 plus 1 is 26. So what is Laplace transform of f dash of t? Laplace transform of f dash of t equals s f of s. So this is f of s. So multiply this expression with s. So it's going to be s divided by s square plus 10s plus 26 minus f of 0. So wherever t is there, put 0. So you have e power 0 into sine 0. Sine 0 is 0. So this entire term becomes equal to 0. So Laplace transform of f dash of t equals s divided by s square plus 10s plus 26. Find the Laplace transform, that is find the Laplace transform of f dash of t if f of t equals t for t varying between 0 and 3 and 6 for t greater than 3. Right? So first I need to find f of s. So what is f of s? F of s equals 0 to 3 e power minus st, f of t is t dt, plus you have 3 to infinity e power minus st, f of t is 6 dt. So this is equal to, so let this be the first function and let this be the second term, right? So you have integral first term into integral of the second term minus integral of the second term into differential of the first term dt. So this is 0 to 3 plus integral of e power minus st. So you have 6 here. So this is e power minus st divided by minus s with the limits 3 to infinity. So here also t is varying between 0 and 3, right? So you have put t equal to 3. So you have 3 by minus s e power minus 3s minus 0 because t is 0 here. Now minus into minus is plus. Integral of e power minus st is e power minus st by minus s again. You already had one s, so it's going to be minus s square with the limits 0 to 3 plus 6 by minus s e power minus infinity minus e power minus 3s. So this is minus 3 by s e power minus 3s, right? Plus 1 by minus s square. Put t equal to 3. So you get e power minus 3s minus e power 0 plus 6 by minus s. E power minus infinity is 0 and you get minus e power minus 3s. So minus into minus becomes plus here. So let me write the expression here. So it is minus 3 by s e power minus 3s. This is 1. So you get plus into minus is minus. So you have minus e power minus 3s by s square. Minus into minus is plus. So you get plus 1 by s square. Minus into minus is plus. So you get plus 6 by s e power minus 3s. So observe, here in this case you have e power minus 3s into minus 3 by s. You have e power minus 3s into 6 by s. So 6 minus 3 is 3. So you get 3 e power minus 3s by s plus 1 by s square minus e power minus 3s by s square. So if required, you can take e power minus 3s common. So e power minus 3s, if I take it common, you get 3 by s minus 1 by s square. So this is equal to f of s. So now I need to find the Laplace transform of f dash of t, which is s f of s, right? So this is f of s. So therefore Laplace transform of f dash of t is multiply this whole term by s. So you get s into 1 by s square plus e power minus 3s into 3 by s minus 1 by s square minus f of 0. So when t is equal to 0, so you have f of t equal to t for t varying between 0 and 3. So when t is equal to 0, t is 0 itself, so it is minus 0. So you have s which gets cancelled, 1 gets cancelled, so you have 1 by s plus e power minus 3s into 3 minus 1 by s. So this is Laplace transform of f dash of t. So in this lecture we have taken a few examples where we had to find the Laplace transform of the derivative of f of t, that is f dash of t, or f double dash of t. You have to extend this, so you would have to find s square into f of s minus s f of 0 minus f dash of 0 and so on, right? So in the next few lectures we shall consider inverse Laplace transform, and we shall see how we can solve problems wherein we have to find the inverse Laplace transform. That means given f of s, how do we find f of t? So do not forget to like, share and subscribe and press the bell icon to get notifications all the further uploads, and thanks for watching.